According to the National Electrical Code, it is permissible to combine a dryer and a range circuit within a single conduit, provided that certain conditions are met. Firstly, the cumulative ampacity of all circuits within the conduit must not surpass 80% of the conduit's overall ampacity. Secondly, the equipment grounding conductor, or EG, must be adequately sized to accommodate the larger of the circuits. Consider an example scenario where the dry circuit is rated at 30 amps and the range circuit is rated at 40 amps. The combined ampacity of these circuits would be 70 amps. Now, assuming the conduit's ampacity is such that 80% of it exceeds 70 amps, it would be acceptable to combine these circuits within the conduit. To elaborate on the equipment grounding conductor requirement, it must be sized appropriately for the larger circuit, which in this case is the 40 amp range circuit. Referring to National Electrical Code Table 250.122, a number 10 American wire gauge copper conductor would be deemed suitable for a 40 amp equipment grounding conductor. In summary, a compliant installation could comprise number 10 THHN or THWN conductors for both the dryer and range circuits, a number 10 American wire gauge copper conductor for the equipment grounding conductor, and a 1/2 inch electrical metallic tubing conduit. Now let's clarify the conduit fill calculations to ensure accurate understanding. The appropriate calculation involves summing the cross-sectional areas of all conductors within the conduit. For instance, if you have 3 conductors each with a cross-sectional area of 0.633 square inches and an equipment grounding conductor with a cross-sectional area of 0.211 square inches, the total cross-sectional area within the conduit would be calculated as follows. Firstly, multiply the cross-sectional area of a single conductor, 0.633 square inches, by the number of such conductors, which is 3, yielding a result of 0.299 square inches. Secondly, add the cross-sectional area of the equipment grounding conductor, 0.211 square inches, to the previous result, 0.1899 square inches, which gives a total of 0.211 square inches. This calculated total cross-sectional area must then be compared against the allowable fill capacity of the conduit to determine compliance. For a 1/2 inch electrical metallic tubing conduit, the allowable fill is typically around 0.31 square inches according to relevant NEC tables. Therefore, in the scenario, the calculated total cross-sectional area of 0.211 square inches is less than the allowable fill of 0.31 square inches, indicating that the conduit is not overfilled. To reiterate, the NEC provides guidelines for combining circuits in a single conduit, including requirements for ampacity, equipment grounding conductor sizing, and conduit fill. Adhering to these guidelines ensures a safe and compliant electrical installation. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements and regulations. The information provided here is for general guidance only and should not substitute professional advice from a qualified electrician or electrical engineer. It is important to carefully consider the specific details of your installation, including voltage, current, conductor types, and environmental conditions when applying these principles. Moreover, local codes and regulations may impose additional requirements or restrictions that must be followed. In addition to the considerations mentioned earlier, there are several other factors to keep in mind when combining dryer and range circuits in a single conduit. Firstly, it is important to ensure that all conductors are properly insulated and rated for the voltage and temperature conditions of the installation. Secondly, the conduit must be adequately supported and secured to prevent damage or displacement. Thirdly, the connections at both ends of the conduit must be made in a professional and workmanlike manner, using approved fittings and connectors. Furthermore, it is crucial to verify that the overcurrent protection devices, such as circuit breakers or fuses, are correctly sized and coordinated to protect the circuits and equipment from overloads and short circuits. The overcurrent protection devices should be selected based on the ampacity of the conductors and the ratings of the equipment being served. In the case of combining dryer and range circuits, the overcurrent protection devices should be sized to protect the individual circuits while also providing coordination to prevent nuisance tripping. Another important consideration is the labeling and identification of the circuits. It is essential to clearly label the circuit breakers or fuses in the electrical panel to indicate which circuits serve the dryer and range respectively. This will help prevent confusion and ensure that maintenance and troubleshooting can be performed safely and efficiently. Additionally, it is recommended to provide a circuit directory near the electrical panel that lists all the circuits in the installation, including their purpose, location, and voltage. This information can be invaluable for future reference and maintenance activities. When working with electrical systems, safety should always be the top priority. It is essential to follow all applicable safety procedures and precautions to prevent electrical shock, burns, and other injuries. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using insulated tools to avoid contact with live conductors. Before starting any electrical work, it is crucial to de-energize the circuits by turning off the circuit breakers or removing the fuses that supply power to the affected area. It is also important to verify that the circuits are de-energized using a reliable voltage tester before touching any conductors or equipment. If you are not comfortable or qualified to perform electrical work, it is always best to hire a licensed electrician to do the job. A qualified electrician has the knowledge, skills, and experience to safely and correctly install, repair, and maintain electrical systems. Attempting to perform electrical work without proper training and experience can be dangerous and may violate local codes and regulations. In addition to the technical aspects of combining dryer and range circuits, it is also important to consider the aesthetic and practical aspects of the installation. The conduit should be installed in a neat and organized manner, following straight lines and right angles whenever possible. The conduit should also be securely fastened to the building structure to prevent it from sagging or moving over time. The overall appearance of the electrical installation can have a significant impact on the value and appeal of the property. A well-executed electrical installation can enhance the appearance and functionality of the space, while a poorly executed installation can detract from its value and create safety hazards. Therefore, it is important to pay attention to detail and take pride in your work when performing electrical installations. In summary, combining dryer and range circuits in a single conduit is a common practice that can be done safely and correctly, provided that certain conditions are met. These conditions include complying with the National Electrical Code, properly sizing the conductors and equipment grounding conductor, calculating the conduit fill, ensuring adequate overcurrent protection, labeling the circuits, and following all applicable safety procedures. By adhering to these guidelines, you can create a safe, reliable, and aesthetically pleasing electrical installation that will provide years of trouble-free service. Remember to always consult the latest edition of the National Electrical Code and local amendments for specific requirements and regulations. If you are unsure about any aspect of the electrical installation, it is best to consult with a qualified electrician or electrical engineer. They can provide expert advice and guidance to ensure that your installation meets all applicable codes and standards. Moreover, regular inspection and maintenance of electrical systems are essential to ensure their continued safe and reliable operation. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems or hazards. Maintenance tasks such as tightening connections, replacing worn or damaged components, and testing overcurrent protection devices should be performed on a regular basis to prevent breakdowns and ensure optimal performance. By taking proactive steps to maintain your electrical systems, you can extend their lifespan and minimize the risk of electrical fires and other safety hazards. In conclusion, electrical installations are complex and require careful planning, design, and execution. Whether you are combining dryer and range circuits, installing new lighting fixtures, or upgrading an electrical panel, it is important to follow all applicable codes and standards, use high-quality materials and equipment, and hire qualified professionals to perform the work. By doing so, you can ensure that your electrical system is safe, reliable, and efficient, and that it meets your current and future needs. Always remember that electricity is a powerful force that must be treated with respect. Taking the time to learn about electrical safety and following proper procedures can help prevent accidents and injuries. If you have any questions or concerns about electrical safety, do not hesitate to consult with a qualified electrician or electrical engineer. They can provide valuable information and guidance to help you stay safe around electricity. Finally, stay informed about changes and updates to the National Electrical Code and local regulations. The electrical industry is constantly evolving, with new technologies and standards being developed all the time. By staying up to date on the latest developments, you can ensure that your electrical installations are safe, efficient, and compliant with the latest requirements.